when we have a square root in the fraction, we need to make sure that the denominator does not have any square roots. It needs to be a rational number. First, let's consider a fact we already know. If we multiply a square root of 7 times itself, we end up with a square root of 49, the product of 7 and 7, which is just 7. So when we multiply the square root of a number times itself, we end up with a rational result, and that's going to be helpful. Let's use that fact to rationalize this denominator. We have 3 over square root of 7. We're going to multiply that by the same square root expression that we see in the denominator. But in order to do this without changing the value of that fraction, we have to use one of our well-chosen ones. In this case, square root of 7 over square root of 7 times the fraction. Let's see what happens. We get 3 square roots of 7 in the numerator and 7 in the denominator, right? Because this is square root of 49, which is 7. That's what we mean by rationalizing the denominator. The denominator is now a rational number, not irrational like a square root of 7. Let's try it down below here. We're just going to multiply that by square root of 10 over square root of 10 because all we're concerned about is cleaning up the denominator. Doesn't matter how messy the numerator gets. So the numerator turns into 2 square roots of 10, and the denominator is now just 10. We can reduce that a little bit by dividing the numerator and the denominator by 2. So my final answer is just the square root of 10 over 5. And that is rationalized. Let's look at some that are a little bit more complicated. These require some extra simplifying. Now you have a choice. You can either change this into the square root of 8 over 20 and reduce first, or you could multiply the top and bottom by square root of 20 and reduce later. I'm always in favor of reducing first, so we're dealing with the smallest possible numbers. So this is what I'm going to do. 8 over 20, 4 is a common factor. If I divide 4 out of both of those, then I get square root of 2 over 5. Now I'm going to change it into 2 radicals again. This is equivalent, and I need to rationalize the denominator. So now I'm going to multiply by the square root of 5 over itself, which is equal to 1. And my result is square root of 10 over just 5. Now remember, we're only trying to rationalize the denominator. The numerator can be as messy as it needs to be. And 10 doesn't have any perfect square factors, so this is your final answer. Let's try this last problem. Now here I cannot reduce 15 and 75 because 15 is not in a square root. So I need to just consider the 75 for a minute. Now 75 is equal to 25 times 3, and 25 is a perfect square. So it's equal to 15 over the square root of 25 times the square root of 3, which is like 5 times the square root of 3. Okay, now if we rationalize a denominator that has a rational part and an irrational part, we're only going to change the irrational part. Go ahead and multiply by that square root of 3 and see what happens. Remember, we have to do it in the numerator and also the denominator. So we get 15 square roots of 3 over 5 times 3, which equals 15 square roots of 3 over 15. The 15s reduce, and we're left with just square root of 3. Now you've seen a variety of examples. Go try some on your own.